All right, hi everyone. My name is Ryan. This is Kim. Today we're going to talk to you about user authentication in Angular applications and some of the things that Angular gives us to make it a bit easier than maybe some other front-end frameworks that we would use. So my name is Ryan Chenkie. I am Angular and Node consultant. Formerly at Auth0, I left back in November to start my own consulting business. I'm a Google developer expert, and I'm also an instructor. I teach at angularcast.io and also front-end masters.
So my name is Maida. I am the technical content lead at Auth0. I'm also an Angular consultant. And before I was either of those things, I was a front-end engineering lead, leading projects, mostly working on AngularJS.
All right, so Kim and I get questions a lot from people that go like this. How do I secure my Angular application? And oftentimes what people really mean is, how do I add authentication to my Angular app? How do I put user login in it and be able to protect resources for that user? And invariably the answer is this. You can't, sort of. It's not a very satisfying answer though. People give us this kind of look all the time. But we tell them front-end frameworks by themselves don't really care about authentication so much. I mean, not in the traditional sense. You know, front-end frameworks are frameworks that power public clients, and they are, public clients by their nature are just that, they're public. They can't have any kind of real sense of authentication in kind of the traditional way we think about it. And one of the ways to think about it is kind of like this. If you were wanting to protect your stuff, your valuables, you wouldn't want to put them on a shelf like this and then put this out in public, because that's not any good way to protect your belongings. Instead, you want something like this. You want to keep it behind lock and key. You want to have something that will keep it behind a safe. You want to be able to go through the front desk, have them lead you back with a key, and only then be able to access your things. So let's think about some characteristics then of authentication in maybe the traditional round-trip application sense. Here's some things we need to do. We need to allow the user to get access to restricted pages and different views and routes that belong to them, to privilege data that only they should be able to access, and then to information that's very specific to that user. So those are some of the goals of authentication. And how do we protect these things in a round-trip app? Well, I would argue that in a round-trip setting, it's really kind of a side effect of how round-trip applications work. So it kind of looks like this in the round-trip sense. Taking it back to basics, the user would submit their credentials. Those get checked against a database. If everything looks good, a session gets created on the server for them, and a cookie gets sent back to the browser where it's stored, and it lines up with that session ID. And that session on the server is kind of this in-memory piece of data that identifies a user. And then on every subsequent request, on every movement forward through the application, that cookie gets sent to the server. It gets checked against that session, and if everything looks good, then the user gets some content back. And that content that the user gets back is going to be the HTML all stitched together and ready to go that's particular to that very movement through the application. That movement that said the user's okay, they can get access to this HTML. And if they're not good to go, well, they'll get an error back, something like that. But what about the case for single-page applications?
Well, in a single-page application, the client is really the dominant player. So you have your app running in the browser, and the app might make calls to an API, or possibly multiple APIs. And typically, the server will send back the response as JSON. So in single-page applications, almost everything happens on the client. Most of what we need for the app's architecture is downloaded to the browser on the initial page load. There's caveats to this, such as lazy loading, but in general, in a single page application, the architecture dictates that there is no full page reload. Therefore, that means if we pull secure data on that initial render, then it exists in the browser essentially for the lifetime of the user's session, the browser session, and possibly longer due to caching. So we don't actually have a super great way to restrict the user's access to that data once it's already in the browser. So what are the characteristics of an authenticated single-page application? Well, they're the same as they would be for any other authenticated app. We want the user to log in and be able to access restricted pages, views, and routes. We want them to get access to privileged data, and they need access to information specific to their user. So how do we solve this when the client is, by its nature, extremely public? Well, we obviously should never initialize our app with anything that should only be accessed with proper authorization because everything on the client is public. So what we really want to do is keep secure data on the server and then only call it when we know that the user is authorized to do so. So how would we do this?
Well, one way that we've got to do this, and there are a few different ways, but one way is through JSON Web Tokens. And if you're familiar with Auth0 at all, you might be familiar with JSON Web Tokens. Show of hands, who might be using JSON Web Tokens in their apps? Okay, a fair number of us. So kind of a newer way, if you will, to do authentication and authorization, and something that Auth0 really likes. If you're not familiar with JSON Web Tokens, they're essentially a string. So this is a very basic JSON Web Token. You can see it's got 3 parts here. And each of these 3 parts separated by dots represent a couple different things. We've got a header, so that's just a JSON object describing the token. We've got the payload, which is kind of the meat of the token. That's where any user-specific data you might have would go. And then the last thing we've got is the signature portion. And the signature is made up by base64 URL encoding the header and the payload together, and then running that through a hash, giving us a signature that is tied specifically to this token and its contents. So what that means for you is that if somebody were able to get a hold of their token and try to modify it somehow, they'd be out of luck because as soon as they do, it would invalidate the token. So with JSON Web Token authentication, it kind of looks similar to the round-trip application scenario, at least at the beginning. We have the user submitting their credentials. They get checked against the database again. But this time, if everything is good to go, a token, a JSON Web Token, gets signed and sent back to the browser. And that's usually saved in web storage, local storage, or in a cookie. You can store them in a cookie as well and use that kind of automatic transferring of a cookie back to the server if you wish. But typically, if you're storing them in local storage, you want to attach your JSON Web Token as an authorization header to every outgoing HTTP request that you make. So what are the things that are necessary then for using JSON Web Tokens in our Angular apps?
Well, we need to recall that client apps like those built with Angular are public. So in order to authenticate a single-page application, the client really needs to remain unaware of the contents of any kind of sensitive data that we would be using. So instead, we need to rely on that data being provided from elsewhere. So let's assume, for our Angular examples, that the JSON Web Token has been signed on the server and it's been sent back to the Angular app. That would have happened in the flow that Ryan just described. We send the login credentials to the authorization server, verifies the credentials, and then returns the JSON Web Token to the app. So how would we go about utilizing the token and managing authentication in Angular? Well, there's 3 things that we're going to need to be able to do. The first one is we need to be able to modify HTTP requests to include the authentication information in the form of adding an authorization header to outgoing requests, and that header should contain the JSON Web Token. We need to limit access to client-side routes. And finally, we want to be able to redirect users to a public route, maybe a login screen or public homepage, if or when they become unauthenticated. So fortunately for us, the Angular platform actually has some really cool features built right into it that help us do these things.
So as people who deal a lot with authentication and identity, kind of by nature of our work, we really like Angular for the tools that it gives us that help us with these things. And the first thing that it helps us with is what Kim described as attaching that JSON Web Token as the authorization header automatically. And for this, we can use HTTP interceptors. So if you're coming from Angular version 1, you're probably familiar with HTTP interceptors. And you may have been surprised that at Angular version 2+, they weren't around when Angular 2+ first arrived. They didn't arrive until version 4.3. I wanted to update that to say 4.3, but I forgot to. So before version 4.3, this had to be done manually, kind of attaching a header on every request you would make. So what we want to use interceptors for is to catch any outgoing HTTP requests, modify that header, and then send them on our way, on their way. The way we would start to do this is we'd pull in the HTTP interceptors provider token. We would say, let's use a class that we're going to make to describe some logic of how we want to make that modification, and then that will be done for us. We would describe our modification this way. We could create an injectable service. We would implement the HTTP interceptor interface. When we do that, we've got to provide this method called intercept, and this is going to take a request and then let us do some work on it. Now, HTTP requests with Angular are immutable, so instead of modifying every request that goes out, we actually need to clone it first and then send that clone out the door. So what we're doing in this example is we're cloning it, adding an authorization header, and then saying, let's go and do the next HTTP interceptor in the chain, if there are more, or just send the request on its way. So what's great about this is it's also really useful for catching authorization errors. So let's say we have the case that the user's token becomes expired and that check is made on the server. And so we get a 401 error code back. Well, we can look for that in the interceptor that takes care of responses. And if we get a 401, well, we know we probably want to prompt the user to log in again. And so we can do something like that here. We can just say, if we get a 401, send the user to the login page.
So the second tool that we have at our disposal when we use Angular is route guards. So route guards are also services. They're services that we can tell the app to run when the user requests a route. We would want to use route guards when we want to restrict access to certain routes. So there's a couple of common ways to decide whether or not a user should have access to a route. Probably the most common way is, are they authenticated or not? Are they logged in at all? And another common way is, does the user have the appropriate authorization level? So if they're logged in, if they need a specific scope or they need to be a specific access level to be authorized to access a certain section, then do they fulfill that? And route guards can be applied on a per route basis. This is particularly useful if you have an application with multiple authorization levels. Maybe you have a public homepage, and then you might also have a section for logged in users, and then maybe an admin dashboard where only authenticated users with elevated administrative privileges should be able to access the content. So route guards implement a few different guard interfaces. The most common one is can activate, and this is the one that will be generated automatically if you ng generate guard with the CLI. The can activate interface will prevent unauthorized users from accessing a route, but one of the important things to remember about this one is that the code for the route is actually already in the browser. So what can happen is a particularly savvy user could potentially hack their way to that code because it's already in the browser. What the guard's actually doing is preventing the UI from loading. The can activate child interface is very similar to can activate, but we can apply it to a parent route and it will then affect all of that parent route's children. And finally, the can load interface is a little bit different from the previous two. This one is intended to be used with lazy loaded modules. So what this one will do is actually prevent the lazy loaded module from downloading to the browser at all if the user does not sort of fulfill the conditions that we set out as a requirement for access. So let's look at a quick example. This code is an example of a route guard implementing the can activate interface. We have an injectable service, we export a class, and so guards return true or false depending on whether we want the user to have access or not. So we would set some condition that can help us determine whether or not the user fulfills that condition. So in this example, let's say that we have an authentication service in our application, and this auth service might provide methods like login, check session to sort of set up the user session after they log in, log out, and maybe token expiration, and we probably want to have a method in this service that just tells us is user logged in or not. So in this example, it's called is authenticated. So because route guards need to return true or false, this method is perfect for using in our route guard to determine this. So we can simply inject the auth service into our guard and use it to make that check. Now, the other sort of useful thing about route guards is they can perform some kind of side effect as well. So if you have a user that's not going to be authorized, you can then redirect them somewhere else. Maybe you want to send them to a login screen, or maybe you want to just send them back to the home page. So this is an example of another route guard. This one is implementing the can load interface. One little caveat, the code that you see here could easily sort of be applied to can activate as well. There's no sort of restrictions as far as you can't check roles in can activate or anything like that. But this simply demonstrates that you could also verify users' permissions or scopes based on route data. So for example, a route might expect a role of admin. So we could use our authentication service to check whether the user who's trying to access the route has that admin role, and then either grant or deny access to the route based on that.
Okay, so the last tool that we'll talk about really quickly here that Angular gives us is async routing. But with the caveat that this is only kind of a way to do security. We would really advise everybody to keep any kind of sensitive information out of your bundle altogether. If you have something that's really sensitive, keep it behind your API where you can do proper authentication checks. But if you need, for whatever reason, to store something sensitive into your application bundle, you might benefit from async routing. And the reason you might benefit is that with async routing, you can have the portion of your application that might have something a bit sensitive only be loaded when a certain route is navigated to. And before that route is navigated to, well, we've got to check whether or not the user should get access to it. Now, again, this is just a very thin level of protection, not really anything that I'd recommend for actual real sensitive data. So again, not a great approach, but it does give us something. So again, we load that portion of the app when the user navigates to it if they have permission to, and only then would that JavaScript bundle be loaded into the browser. And we check this with the can load guard. And it looks a little bit like this when we're setting up our route definition. We would we'd say load a child module when this route is loaded. And we want to apply our guard that Kim was talking about just prior, the role guard, with an expected role of admin. So it's nice that we can apply any kind of arbitrary data like this to our route definition. We can say we want to expect a certain role. We could extend this to be we expect a certain scope, or any kind of way that we describe the permissions level that needs to be there for our users to navigate in our application. So again, 3 really great tools that Angular gives us: HTTP interceptors, we've got route guards, and async routing. And I guess the thing we would say is that Angular gives us a lot of tooling for this out of the box, whereas some other frameworks might not do so. So we've got a much easier time when we want to go to protect our applications.
So we have a couple of resources that you can check out if you want to sort of learn more about this, see it in action. There's an authenticated Angular application in this repo on GitHub. It has sort of working examples of everything that we've seen. There is a real-world Angular series. This is an 8-part series building a mean stack application all the way from sort of ideation, architecture, through authentication, authorization, and then production deployment with SSL. And these slides are also available at this link if you want to check them out on your own.
And for anyone who's interested in kind of end-to-end security for their Angular application, I've got a book coming out shortly. It's at ngauthbook.com, and that'll take you through kind of user authentication, authorization, and also some other things to consider when securing your Angular application. So thank you so much for being here. We appreciate you guys listening to us, and if you have any questions at all, we're happy to talk to you out there.
Oh.